All right, here we go. The last homework before the test. So this is homework 1-9. And starting off with a couple of my favorite problems here. Here's what you're supposed to do. You're supposed to look at these pictures and without doing any kind of calculations, without calculating, you are supposed to determine the average of these pictures, which one would have the smallest average, and then the next smallest, or the next biggest, up to the biggest average. All right, so I'm going to talk through a couple of these to help you get the hang of this. Here's my thought process when I do these. I'm just going to start with these, just comparing these two graphs right here, this one and this one. All right, so we're going to just start by looking at those, and notice they are very similar. Boom, that's exactly the same, exactly the same, exactly the same. Now we got a little difference going on in this next one. Both of them have a 9, both of them have an 11, but this 12 block basically got moved and is now a 10 block, okay? So I know just by based on these numbers right there, that B is going to have a bigger average because it's got a bigger number. It had a 12 block where this has a 10 block. So if I were to add up all these blocks, B comes out bigger than A. So I know, or D, I'm sorry, B is bigger than D. So I think you have to put these from smallest to biggest. So that means D is less than B. All right, the mean of D is going to be less than the mean of B. All right, so let's clear things up a little bit. Let's see here. Well, all right, so let's look at doing A and B. Okay, comparing these two. So if I'm trying to compare those two, A and B, what do they have in common? They both have a 12. They both have an 11. Boom, boom. They both have a 9, right? They both have 3 on 7. So that's all still the same. The difference occurs down here on this end. And basically what happens, this has 2 4 blocks. This has a 4 and a 5. Okay? So this means A is going to be a little bit bigger than B because it's got a 5 and a 4 where this one has 2 4s. So A is going to be bigger. So that means B is smaller than A. So B is less than A. Okay? There's my less than right there. All right, so let's compare. We've compared A and B. We've compared B and D. We left C out of it, so let's get C involved. And let's see if we can compare it with A since it's right above it. It's got the same there, same there, same there, same there. Here's where it changes. This has got, so you got to think about, okay, what's this little situation right here? Which one has the bigger numbers? And C, these numbers turn out to be, if I added them up, would be bigger than these numbers. I don't have to add them up. I'm just saying, I can look at them and say these numbers here are bigger than those 3 numbers there, which means C is going to be bigger than A, or say it the other way, A would be less than C. A would be less than C. All right, so I think I got, from just this, I think I've got enough information. Sometimes I have to do a few more comparisons, but since I know that A is less than C and B is less than A and D is less than B, well, just based on, let's say, based on this right here, I can say that D, B, A's got to happen, and then A is less than C, so C's got to go over here. That should be the order of these means. They should go in that order. D being the smallest, B being the next, A being the next, and then C being the biggest. All right, let's try another one. Because these, what I don't want you to do is sit there on your calculator. I mean, you can do that but the efficient way is and the way to try to understand this stuff is not sit there and punch these numbers in a calculator. It's to be able to look at it and figure it out. So let's try another one. Let's just start here, and you can pick whatever two you want. I'm just gonna worked well for me last time to go with B and D, so I'll start with them again. So let's look at these numbers. Same, 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 same. Here's where it's different. Okay, so looking at those, which one's going to be bigger? Yes, you're right. D is going to be bigger than B. So I'm gonna write it the way I'm saying it this time. Just so it says D is going to be bigger than B. All right. Let's do these two this time. Same, 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 same. Here's where it's different. Okay, so which one's bigger? Yep, A is bigger than C. All right, good enough. Let's keep going. Let me see if I can erase some of this to clear things out so we can do a few more comparisons. All right, so let's go with A and B this time. Same, same. All right, so it's going to be different here. So what happened? They both have a 5, but it looks like this little block here is this block here. Okay, so if you're noticing that, then A would have to be bigger than B. A would have to be bigger than B. So A is bigger than C, and A is bigger than B. Let's compare these two. Let's see, we got the same here. What's going on? We got the same here. We have the same here and here. But here's where things change. This has 2 5s. This has a 5 and a 3. So that means C is bigger than D. C is bigger than D. All right, do we have enough in order to figure out what's the biggest, what's the smallest? C's bigger than D. D's bigger than B. It says A is bigger than C. So it looks like A is going to be the biggest. A is bigger than C. C's bigger than D. And D's bigger than B. So this is in from biggest to smallest. And then if I wanted to switch that around, if they asked me from smallest to biggest, I would just flip-flop those and put them in a different order. So it'd be that first, then that, then that, then that. Okay, those will take some practice. For your brain to grow a little bit, try to do this without just punching these numbers in a calculator and finding the average. All right, let's move on to the. These won't take as much. These won't take as much thinking probably. Here you're approximating the mean or what you think of the average given a frequency distribution. So basically it says here we've got 10 people or 10 students that these are the number of hours per week they work. Okay. And you have 79 respondents to this survey. So it shows that number of hours worked per week, you have 10 people that work between 26 and 30. 24 between this number and so on down the line. Now, I don't know, out of those, let's just talk about this. Out of these 10 people right here, I don't know if a couple of them work 26 and a couple of them work 27 and one of them work 28, but I just know that all 10 of these fall somewhere in here. So what I'm going to do is take the number right in the middle here, the number right in the middle, which would be between 26 and 30, that would be 28. And I'm going to say that all 10 of these people, I'm just guessing, I'm estimating that to be, I'm taking that middle number and saying all 10 of those people work 28 hours. All right. And same thing here. I'm going to take the middle number, which would be 33, and say all 24 of those people work 33 hours. I'm going to go to the middle here. That would be 38. All 20 of those people. I'm going to estimate it to be all 20 of those people working 38 hours. Same thing here, be 43 times the total number in there, be 12. Then I got 48 times 8. And last group would be 53 times that 5. All right, so what I'm going to have to do to find the mean is I'm going to take these numbers. I'm going to get those. I don't have my calculator, so you are going to have to do this on your own. I'm not going to get a final answer here. That's going to be 280. All right, this is going to be a certain amount. That's going to be a certain amount. That's going to be a certain amount. Certain amount. Certain amount. I'm going to add all those up, get my total, and then I'm going to take that total and divide by the total number of people, which it said it was 79. So I'll divide that by 79, and that'll give me the mean of this data right here, okay, or the estimated, approximate mean. Okay, it's not the exact mean because I don't have the exact scores for all 79 of these people. So we had to estimate by taking the middle number in each of these different classes here. Okay, so you take the middle number here, multiply it times the frequency here, add up all of those numbers, and get your grand total, and divide it by the total number of respondents, and that should equal your average, or your mean. All right. And then this next one, let's see if I can, this next one here, I'm going to do a little erasing so I can read it. Oh, no, that's the same problem. Sorry, it says use the midpoint. All right, moving on to the next problem. Okay, so really similar to what we just did in the last problem. Here you have a histogram. You're going to approximate the mean again. Okay, so remember if you remember what we did in that last problem, we took the middle number and we multiplied it times the frequency. We're going to do the same thing here. We got a frequency of 5 here in this first bar. We're going to take the number right in the middle, which in this case would be 870. So I'm going to say 870 times that frequency. Come here and do the same thing in this one. That middle number would be 890 times the frequency. Do it again here. Middle number would be 910 times the frequency. 930 times the frequency. 950 times the frequency. I'll get those numbers. I go to my calculator. I type those things in. Get a total there, total there, total there, total there. Add them all up to get a grand total, and then divide by the total number of frequencies. And then usually they tell you that in the problem here. In this case, it's 32. So in this case, I divide by 32 and get my mean, or estimated mean, for this histogram. Again, it's not the actual mean because I don't know the exact value of these 5 or 7 or 12 scores. But we're estimating that they're somewhere in the middle here. Okay, so to recap, you're getting these numbers here from the middle of each bar, of each histogram bar. You're estimating that those 5 values are 7 or 12 or 6 or 2, they're going to be, average out to be somewhere in the middle of that bar. So we're taking the middle numbers, multiplying them times the frequency of each middle, getting those values, adding all those values up to get our grand total, which we'll divide by the total number in the survey or the experiment here, which is 32, and that'll give us the mean. All right, what do we got last? I think I saved the easiest one for last. Yeah, so here we are just doing a weighted mean. You have 33 customers. Customers were asked the prices of the computers they had bought. The data are summarized. So you had six people, 6 computers that were bought for $1,700, 18 that were bought for $1,900, and 9 that were bought for $2,600. Find the mean price of the sample. All right, so basically there are 33 numbers here, okay? 6 of those numbers are 1,700. So I could sit here and I could say 1,700 plus 1,700 plus 7, and I could do that 6 times. And then I could say plus, I'd have 18 1900s. I'm not going to sit here and do all that. But I could do that all the way up to my 18th 1900. And then I'd have 9 2600s. I could, keep adding 2600 9 times. Got a big total. And then divide it by 33. And that would give me the mean. All right, so quick way to do that, though, instead of adding up 6 1700s, I'm just going to say 6 times 1700 plus 18 times 1900 plus 9 times 2600. Get that total, divide that by 33. That's going to give me my mean. Okay? So we are multiplying that times that, that times that, that times that, getting a total, dividing by 33, which in that case is the total of those total frequencies there. All right. Good luck with that. And then I'm going to be posting a practice test. If you're listening to this, it's probably already posted. So make sure you pay attention to that. And make sure you've worked through those problems on the practice test so you're ready for the real test later this week.